quadratic coefficient's always positive. It is. So I would move the 14R and the 49 to the left. So plus 49. Always look for a GCF, but there is no GCF up here. And then lastly, factor like we've been doing. We have A, B, and C, and from that, factors of what? Factors of A, factors of C. Okay, 1 and 1, that's nice when A is just 1. 49, not too many options, is there? Oops, 7 and 7. Okay, as we make our guesses for the umpteenth time in here. 7 and 7, 1 and 49. What do we know about our signs? Signs have to be the same. 49, it's positive. Plus plus, minus minus, it's negative 14. So the only thing we can have with that is negative negative. And then figuring out a negative 14 out of that. The only way to get negative 14 out of that are the 7s. Now, from this point on, we're solving. So we got to go that last step using what we call our zero product property. We set each quantity to 0. And what is the thing that happens about these two quantities? They are one and the same, aren't they? So I keep telling you, typically we get how many solutions? 2. But there are some exceptions to that. And, well, this is one of those exceptions, isn't it? Because, well, both quantities are the same, aren't they? And because both quantities are the same, you get the same solution. When that happens, we don't get 2 solutions. We get just a single solution. We get R to be 7. Okay, and with that R equaling 7, this is just a 1 solution to the quadratic, which is fine. It definitely happens. Okay, and we'll talk about again kind of what happens with that graphically a little bit now this week here. But as I've kind of got you with that, what that means on in this instance here, x squared minus, what was it, 14x minus, nope, it was plus 49, wasn't it? So what that means for us is we've seen so far these quadratic graphs. They've been so far crossing through our x-axis at 2 locations. Those are, again, our x-intercepts. Those have been where it's crossed through that. What we're going to start doing here is connecting our solutions to our x-intercepts. Now in this instance, when I graphed out the equation we just did, how many locations is our, how many x-intercepts do we have on this one? We have 1. It's intersecting it right here at 7, 0. Because the x-intercept is related to our solutions. So in this instance, it's sitting on top of the x-axis at 7. There is going to be our connection that we're going to make later on this week. Okay, so just something small there for us to tie into. The last one there, it's good to go. It's in standard form. There is no GCF up there. We're stuck with 7. We're stuck with 16. We're stuck with negative 15. No big deal there. We've been doing this one for now quite a while. Now after that, 7 builds it, 7m and 1m, and then 1 of each, don't we? Gotta have 1 of each. It's a negative 15. The only way to get negative through multiplication is 1 of each. What is it? 1 and 15 or 3 and 5? You gotta get up to a 16. Okay, now I can't, again, when it's 1 of each, that's where it's part of your guess and check. Right? Positive and positive, it doesn't matter. Negative, negative, it doesn't matter. But it's 1 and it's positive and a negative, you got to figure out where does those go. That's part of you developing that skill of a guess and check. To get, again, getting up to a a 16 is what we want. Based off the solution I'm seeing here, we're using the 3 and the 5. And in this instance, we're always, that's the guess I'm checking in my head. And 5 and a 3 is doing that for us because 7 times 3, hey, in my head, I'm thinking, no, that's a 21. 5 is going to give me some combination. It's either 26 or yeah, 6. Yeah, thank you. I lost track there. Adding up to be a 26 or subtracting to be a 16. That's what I'm sitting here doing in my head until I have a brain fart. Okay, that's giving me that 26 or a 16 out of that. Okay, and in this great case, yeah, that's where we want that plus and minus out of there. 16 is the positive, so I want that 21 to be the positive. That's it. But we got to use our zero product property. So we go that last step then because we're solving. And that's where we get the two solutions. 7m minus 5 and m plus 3. Now, do I necessarily need to show that step? I know some of you can keep track of that in your head very carefully. Fine, you could go right to our two solutions. 5 over 7, and the other one, which is negative 3. And we're back to our two solutions again. We're back to, if I was to graph that out, we're going to see that graph go through at two locations then. Okay. Good questions there. Graphing again is never going to go away. Eva?
4C.
4C. Down the bottom, or is it the top of the next page? Previous page. All right, 4C. 4C, f of 2. That should be negative 1. Okay, so f of 2. Okay, this is where we're reading that graph. Remember, as we did on Friday, where it said f of 2 when that parentheses is there, when it says x is 2, what is the output? The input's in 2, where's the output? So when you go to the x-axis at 2, well, the graph is located right here. And that location should be 2 comma what? And that's a typo. It should be at negative 1. That output is at negative 1, not negative 2. Negative 2 is right here. That line is clearly not there. So, ouch. That is clearly just what? Negative 1. Thank you. I'll update that. Anything else anybody's got? Okay. Make sure your name's on it. Fill in the basket. Get out your packet of notes. Try to finish this up here. Let's think a bit more with functions here today. And we'll go on there, guys.
Oh my gosh, I need one too.
First off, we've been doing the first two parts, okay? We clearly have a function. That's the quadratic function. And then the domain. Somebody, what do you have for the domain out there? What would you say for the domain? But what we have? Domain is what? Negative infinity to positive infinity. So that domain is from left to right. It's the x's. We don't have any walls, do we? Because this graph keeps going to the left, 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 forever and ever and ever, meaning it is starting at negative infinity. And I don't have a wall on the right. I can't put a wall on the right, and it keeps opening up to the right, ever and ever and ever. That means it's going from positive infinity. We're using every x value from left to right to make that graph. The range. What somebody say for the range, I should say. What's my range here? Negative 2 to infinity, I think Brianna said, right? That is correct. Our range is the y values. Now, when we say our range here is negative 2, starting off at, that's my floor, I like to call it. I can put a floor in here starting at negative 4. And we use a bracket. Hopefully you realize we get a bracket there because it's solid starting at negative 2. And then she said to infinity. I can't put a ceiling up here because we're also going left and right. We're also going all the way up, 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 up to infinity. All the y values keep increasing forever and ever and ever. So infinities always get a parenthesis, right? All right, so then let's add in the new part for today. The increasing and decreasing intervals. So when we talk about the increasing and decreasing intervals, first off, we're looking at the domain. Okay, we're looking at um, the domain interval here. Okay, from negative infinity to infinity. So first thing we're going to do is label what your eyes are doing. So when you look at this graph from left to right, what is this left-hand side of this graph doing? Is it increasing or decreasing? It's decreasing, right? So let's go ahead and label this as decreasing, okay? And at some point, your eyes start to turn, right? And then they start to do what? Increase, right? Where do they start to increase at? They start to increase right about here. Bless you. Somebody tell me, what point did your eyes start to increase at? What point did they start to increase at? 2 comma negative 2, right? On this particular graph, the vertex is where they switched, right? Now that vertex is a huge point. We'll talk about it again this week. The vertex is huge on here. But when you said 2 comma negative 2, it's the x value that I'm concerned about. The domain I said a second ago is where this is coming from. This is coming from the domain. And on you said 2 comma negative 2, the 2 is the domain. The 2 is your x values. So everything's happening off of the domain. We want to train our brain for looking at the x's. So when we say this is decreasing, I want you to tell me what x values is this graph decreasing over, okay? Decreasing on. So this decreasing here, as you said, starts off where? It starts out here at negative infinity. It's decreasing. So you're just doing like you do on the domain. It's decreasing way out here. It's decreasing way out here. And then where did it turn at? Where did it flip to start increasing at? What x value? 2. So where it flipped is where it's going to stop. And then what happened to it? It started to increase, right? So right there, we're going to pick it back up. And then what happens forever and ever and ever? It keeps increasing as x's go to where? Back to infinity. So all we're doing here is taking that domain and throwing in kind of a pause of where it flips from decreasing to increasing. So if you get the domain down, you're pretty solid. You just got to find that very special place where is it flipping from increasing to decreasing or decreasing to increasing, whatever the case is doing. Now I haven't put a parentheses or brackets here. And this is the one time where students get a little confused on. I'm going to use a parenthesis because at 2, it's neither increasing nor decreasing. 2 is that switch where it's flipping, right? So on the increasing and decreasing interval right here, typically we put a parenthesis on that because that's where it flips, okay? So at 2 is that special location where, again, it changes from decreasing to increasing. So usually at 2 is where we'll use a parenthesis where it goes from one to the other, okay? So if you were then to take these two increasing, decreasing intervals and smash them back together, you should always get the domain in return, okay? So we're going to take our domain, kind of split it apart, and you're going to split it apart to wherever you said it flips from increasing to decreasing, okay? Let's do another one. Letter B. Take a second, tell me what the domain is, tell me what the range is, all right? And then we're going to label where is it increasing and decreasing at, and then we're going to find that split, okay? It's clearly another function. It's the St. Louis arch. It's opening down. It's another quadratic, okay? And what's that domain doing here? Is the domain the same? Is it negative infinity to infinity, or is the domain got some walls up there? Is it finite walls? No, the domain is the domain is negative infinity to infinity, isn't it? So I don't have any walls up here, do I? That domain is negative infinity to infinity all over again, isn't it? Same question on the range. Do I have any floor or ceilings on this one? Or is it infinity, negative infinity to infinity? So, do I have a floor on this one? No, this one is clearly opening down forever. So, I have no floor. And in this instance, no floor means I have negative infinity to start off with. Do I have a ceiling at least? St. Louis Arch has a ceiling, which is happening at 4. So all I need for the range is from negative infinity up to 4, and I can stop at 4. All right, that's the old stuff. Now, the new part from today is coming from the domain, the increasing or decreasing. So again, what I always have my students do, my Algebra 1 kids, we did a ton of this last year. What's the left side of this graph doing? Trust your eyes. What are your eyes doing from left to right? First, they're increasing, and then they are decreasing. And tell me where they flip at. What is that? What is that point where they flip at? 2, 4. And the reason why I really want that point is because it's the x value that does it, not at 4. What is the 4? The 4 is the y value, isn't it? It's always at the x because the increasing and decreasing intervals is coming from the domain. 4 is not in the domain. 2 is the domain. Okay, so now let's go ahead and make the intervals. This thing is increasing from left to right. So it's increasing this time from left to right. So from negative infinity, our eyes are coming up. And where is it flipping at? Flips at 2. And then from 2 on, where is it decreasing? 2 on to infinity. So our eyes keep decreasing as the x's go to positive infinity. So as you keep saying 4, 5, 6, 7, 8, 9, 10, 100, and 1 million positive infinity, our eyes are keep decreasing forever and ever and ever. Now, just like I did on the last one, where that x value is at, I always put that as a parenthesis there, because at that parenthesis, that 2 value, that x value, it's neither increasing nor decreasing. And again, if you took these two, smashed them back together, all right, smash these two back together, it should make the domain. Okay. All right, let's go with another one. All right, I don't expect those mastered yet, but let's go with another one here. How about C? Let's go with one more here. Now on C, the domain here in the range, that's nothing too crazy. Now first off, this is a function. Left to right, are we overlapping at any time? This is okay. It's a bit of an odd function, but this is what we call a piecewise function. My Algebra 1 kids, we talked a little about piecewise function because it's in pieces. Okay. The domain, left to right, I do have a wall this time, don't I? I do have a wall here. It's not starting way out here. It's only starting here at -2, which is a bracket. Comma, and it stops at the first one. It stops here at 0. And we did a little bit of this work last week, where it has a bit of a space in between, doesn't it? It jumps. It goes from 0, and then the graph picks up at 1, doesn't it? So when we did that last week, we said we call it a union. No big deal. It starts back up at 1, and then it stops again at 2. And where it stops again at 2, it's closed. Sorry, it's open. It's open. So it gets a parenthesis. So nothing really fancy on that one. It's just we get a little space in between there. And I'm not going to put those walls up because it is going to get a little messy there. Now my range, bottoms up, people. I'm starting down here at a floor of 5. And I'm going up, I'm going up, I'm going up, Nothing's stopping yet. No spaces in between. No spaces in between. I'm not stopping yet. And I finally stop here at a ceiling of 4. So I started down here at 5, which is open. And I did stop up there at a ceiling of 4, which is a bracket. Okay. Now, this last one here is, I like to do this one only because here we can see this one here. Our eyes are clearly increasing on this one, and what our eyes are doing on this dude. So this one has a specific increasing interval and a specific decreasing interval. So here on this one, this interval is specifically increasing on the x values from what to what? From -2 to 0. Here's where things get a little annoying. We usually again do -2 to 0. Okay, with the parentheses. If you put bracket, I'm not going to kill you. This is our first time through it. Okay. And where's our graph decreasing at? Which interval is decreasing? It's decreasing from where to where? 1 to 2. Okay, if you put bracket there, I'm not going to kill you or anything like on that. So our domain, it's coming from the domain. I'm always pulling it from the domain's values. So that these will always make the domain out of that. All right, let's do one more here. Letter D. It's a function. We've talked about that function before. That function is what we call, bless you, that function is what we call the square root function. Now that square root function, we have our domain. It's pointing, starting way out here. There's no wall on the left side. Okay? There's no wall on the left side. That's the square root function. Okay? So it's starting way out here at -infinity. But there is a wall right here, isn't there? Stops here at 4. And as we can see, it's closed there at 4. So there's a bracket. We do have a floor. I think it might still wall earlier, I'm not sure. But now we do have a floor here at, for a range at 0. Do we have a ceiling? We have no ceiling, do we? Because this graph, again, keeps going up, 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 and forever. So no ceiling. Now, so far we've seen increasing and decreasing. What's the only thing your eyes are doing on this one from left to right? Left to right, your eyes are only doing what? Decreasing. This one is not doing anything with increasing. So we don't have any increasing happening here. We read it from left to right, so this is not increasing at all. So it occasionally happens where we have one and not the other. We have both. Okay. So tell me where it's decreasing from left to right. It's always coming from the domain. It's decreasing from what to what? -infinity to 4. If you use a bracket, that's fine, but typically we'd say a parenthesis. Okay? It's coming from the domain. It's the x values we're looking at. What is it decreasing over? What x values is it decreasing over or increasing over? What the case is asking about. Okay. All right. That's how we start analyzing. Continue to ask our questions about analyzing. There's a few more questions out there when we analyze graphs. But these are the beginnings of our big questions there. Domain and range, we're getting better at those, and then increasing or decreasing are the next ones. Okay. All right, I'm going to pause it there. I'm not overly concerned about that one or those we talked about last week. I just had some extra out there. What I'm going to pass out to you here is from Friday. Just a second here. All right. So from Friday here, we had taken on Friday.